Hi guys, so in this video, we are starting a new unit. Yay! Acids and bases. So today we are going to talk and kind of define the properties of acids versus bases. I'm going to give a very, very brief definition of what makes something an acid versus a base. We'll talk more about that like next week, and you'll get to like really dive into the definitions of acids versus bases. But I'll give you a brief definition today, and then we're going to learn how to name acids. So you guys probably know, since you have seen several acids, that we name them slightly differently. So today is the day that you're going to learn how to do that. So we're going to start by talking about just the properties of acids and bases. All right, so in general, we're going to start with taste. So in general, acids or things that are acidic are going to taste really sour. So I think of like a lemon, lime, any kind of citrus. Those are all typically very acidic, have like pretty low pHs. And so those are all things that are like really sour. Vinegar, things like that, acidic, pretty sour. And then bases taste bitter. Now, I always have a hard time thinking of foods that are basic because it always seems like most foods are pretty acidic. But apparently, kale is pretty basic. And I personally think that kale tastes pretty bitter. So acids are sour, bases are bitter. Okay, feel. So kind of like what's their texture? All right, so acids are they just feel like water. So they're their texture is just like very similar to water. Nothing crazy there. But bases are really slippery. And this makes sense because most soaps are basic. So bases are really slippery. Now, the next thing is our safety terms. So kind of what we mean here is if I was looking at like a safety data sheet, something like that, how would it refer to this solution? How would they like warn you that this is an acid or a base? And so for acids, they are called acidic. So if something is an acid, it's acidic. And bases, yes, we use basic, but really kind of our term that we really use is alkaline. And they are used interchangeably, so you can also say basic, but alkaline is typically used. Then we have pH. So pH is power of hydrogen, is what it stands for. It's basically how we measure the strength of acids and bases. So for acids, our pH is always going to be less than 7. And the lower the pH is, typically the stronger the acid. All right, and then for bases, our pH is greater than 7. All right, and again, for bases, the higher the pH, the stronger the base is. And then right at 7 would be neutral. Okay. And then for these next two, we have litmus and phenolphthalein. And these are both what we call indicators. So litmus and phenolphthalein are indicators. Basically, an indicator is something that we can use to determine the pH within a certain range, something like that. But it's just basically a substance we can use to indicate if something is an acid or a base. All right, and certain indicators have different ranges that they work in, and they work in different ways. These are both indicators that are very just is it an acid or is it a base? So some are really specific, like this is a base within pH of 10 or whatever. And then others are less specific. So these are just, is it an acid or is it a base? And so the first one is litmus paper. And so litmus paper, we have blue litmus paper and we have red litmus paper. And litmus paper turns certain colors depending on if it's put into a base or into an acid. So for acids, if you have blue litmus paper, it's going to turn red. So if you have blue litmus paper, it'll turn red. If you're using red litmus paper, it just stays red, doesn't change. And then for bases, red litmus paper turns blue. So again, if you have red litmus paper and you put something basic on it, it'll turn blue. If you have blue litmus paper, it stays blue. So just a very basic, is it an acid, is it a base? That's all it tells you. Doesn't tell you anything else, like is it a strong, weak, nothing like that. Just is it an acid or is it a base? And phenolphthalein is kind of similar. So phenolphthalein is actually a liquid. It's really useful. We use it a lot in titrations, actually, which is basically a type of experiment we can use to determine the pH of an unknown acid or base. But phenolphthalein is like very useful in those. And so phenolphthalein is also just very kind of like, is it an acid or is it a base? If it's a liquid, you'd pour a couple drops in it and then see if there's a color change. So if it's an acid, phenolphthalein remains colorless. But if it's a base, phenolphthalein turns pink. And it's not just like kind of pink, it is hot pink. So yeah. So this is something they use a lot because when it starts to turn pink, you kind of have reached an equal point in your acids and bases. So yeah, that's what we've got here. We've got just those properties. So acids are sour. Their kind of feel, texture is like water. We would say that they are acidic. Their pH is less than 7. They turn blue litmus paper red. And in phenolphthalein, they are colorless. Whereas bases are bitter. They feel slippery when you get them on your skin. They are alkaline substances. Their pH is greater than 7. Red litmus paper turns blue. And in phenolphthalein, it is pink. Okay, so the next thing I want to do is I'm going to give you guys some really brief definitions. And these are something that we will talk about more next week. So we're going to kind of go into these and actually look at, would this be an acid or a base? So we are going to start with our Arrhenius definition. So there's kind of 3 actual definitions of acids versus bases. But we are only going to look at Arrhenius and Bronsted-Lowry for right now. And so I'm going to start with this one. So in this definition, acids, when they ionize, they have to contain hydrogen. So when it ionizes, ionize means break apart into ions. So when the acids break apart into ions, and it has to have a hydrogen ion in it. So it has to break apart to have a hydrogen ion and something else. And then bases would have to basically ionize to contain hydroxide. So basically, to put it like really simply, an acid has to have hydrogen, base has to have hydroxide. Obviously, there are some drawbacks to this definition because not every single base has hydroxide in it. All right, and then that's kind of our first definition. Acids have hydrogen, bases have hydroxide. Our next definition is the Bronsted-Lowry definition. And so in that definition, our acids are going to donate a hydrogen. You'll also see it called a proton. So donate a proton, whereas bases are going to accept a proton or a hydrogen. So we'll look at those next week. You guys will kind of talk through them. So don't worry too much about if that was what does that mean? Because we will go through those next week and we're not going to test you guys over any of the rules yet for that. Okay, so we are going to now move into talking about nomenclature. So for acids, there are 3 rules for naming acids. So we can name any acid whether it exists or not. So first off, the first thing we need to figure out is my acid a binary acid or a ternary acid? So guys, remember, if we have a binary acid, it's just made up of 2 elements. And then ternary acid would be 3 or more elements. So kind of what we have here is for our ternary, it's going to be our acids that contain polyatomic ions, and our binary aren't. And I guess I should probably also tell you guys, how do we know something is an acid? So all acids should contain hydrogen, should start with hydrogen. So if it starts with hydrogen, it's an acid. If it starts with hydrogen, it's an acid. So yeah, first thing we would do is, does it start with hydrogen? Yes. Awesome. All right, let's go ahead and name it. So is it binary or ternary? All right. So if it's a binary acid, we are going to add the prefix hydro and then the name of your anion. Change the ending to from I to ic. So change the ending to ic. And then add the word acid. It's like HCl is hydrochloric acid. And then for ternary, do not use the prefix hydro. We're only going to use the anion, and we actually have to look at the ending of our anion for this one. So there's kind of 2 options here. So if our anion ends in 8, then we change it to ic acid. And if our anion ends in ite, then we change it to us acid. So I kind of made this like summary chart down here that I think is kind of helpful, hopefully, that just kind of goes through. So if it ends in 8, change it to ic. If it ends in ite, change it to us. But we also have a little phrase that we use to kind of help us remember this as well. So the phrase is, last night, all of us ate something icky. Oops, my Y looks very weird. All right, so last night all of us ate something icky. So that shows us that ite, or helps us remember, ite goes to us. And then ate goes to ic. And again, guys, these are typically going to be polyatomic ions that we're looking at here. All right, so this is just a little summary chart with the rules that I made. Take it or leave it. But we're going to go ahead and start practicing. All right, so our first one, and this one's written a little weirdly, but I'm going to rewrite it for you guys so that you can kind of see. I do think that this is a polyatomic ion, but it's acetic acid. And so it's written a little weird. I do think that like is on there, but basically what it normally looks like is HC2H3O2. The way it's arranged is just kind of typically actually how it's written when it is an acid. You'll see it both ways, but it's just written kind of weird. I do think that arrangement is on your polyatomic ion sheet, if I'm not mistaken. I could be mistaken, but it should be there. Okay, so first thing that we need to do is we know it's an acid because it starts with hydrogen. So then kind of the next question we would ask ourselves is it binary or is it ternary? And this one is going to be ternary because it's made up of 3 different elements. So we have a ternary acid here. Okay, so if we have a ternary acid, we need to figure out what is our anion. So hydrogen's always going to be our cation in these acids. So we need to figure out what is our anion. So I'm going to look at the second half here. All right. So I have C2H3O2, and that is acetate. Yes, C2H3O2 is acetate. All right. So it ends in ate. So we're going to change that ending to ic and then add the word acid. So it's going to become acetic acid. Okay. Now then we'll look at the next one. So we have HBr. All right, HBr. So this one is going to be a binary acid because it's just made up of two elements. So because we have that binary acid, we have to add our prefix. So I'm going to add my prefix of hydro. All right. And then I need to, again, look at my anion. So here, my anion is bromide. All right. So I'm going to change my ending to ic and then add the word acid. So it would be hydrobromic acid. So hydrobromic acid. All right. So then next we have HiO3. HiO3. Okay, so again, we have a ternary acid. So we have to look at, so it's ternary, so we know we're not using any prefix. So we have to look right here at our polyatomic ion, which is IO3. So IO3, that's iodate. All right, so it's going to become iodic, because 8 goes to ic acid. Okay. All right, so then in our next one, we have H3PO3. All right, so H3PO3. So this is, again, this is it. It is an acid because it starts with hydrogen. It's ternary because it's made up of three elements because we have that H, and then we have P, and we have O, so made up of three elements. So we have to figure out what our polyatomic ion is there at the ending. That is phosphite. So it ends in ite. So ite is going to become us. So, and so what you might think it would become is you might think it would become phosphus acid. Okay. Phosphorus and sulfur are like the two ones that are kind of weird. So instead of being phosphorus acid, it's going to become phosphorus acid. Just sounds a little less weird. So we do add like that, the R basically, and then sulfur kind of does the same. So instead of being sulfus, it's sulfurous, everything like that. So it's just like phosphate and sulfate are the two that you would kind of add that like weird ending to. So instead of being phosphorus acid, it's phosphorus acid. All right. And then our next one, we have H2S. That is binary because it's made out of two elements. Our anion is sulfur. So it's binary. So we know we're going to add the prefix hydro. So hydro. And then we're going to change our ending to ic. Once again, it's sulfur. So it's just, you're going to write out sulfur and then add your ending to that. So sulfuric acid. Again, phosphorus and sulfur are the only two that have like spelling exceptions, basically. So phosphorus acid and sulfuric acid. Okay. I'm going to do the next 2 with y'all, and then I'm going to leave you guys 8, 9, and 10 to practice on your own. Okay, so number 6, we have HNO2. All right, so HNO2. So again, is it an acid? Yes, starts with hydrogen, so it's an acid. All right, and then we have to look at our, is it binary or ternary? This one's ternary because it's made up of 3 or more elements, hydrogen, nitrogen, and oxygen. So we have to look at our anion there. So I have NO2. It's nitrite. All right, so ite becomes us. So I have nitrous acid. Yeah? All right. And then finally, our last one is HClO3. So HClO3. All right, so is it an acid? Yes, it is an acid because it starts with hydrogen. And then is it binary or ternary? So we have to look at, is it binary or is it ternary? And this one is going to be ternary once again because it is made up of 3 elements, so hydrogen, chlorine, and oxygen. So now after we do that, we need to look at what is my polyatomic ion or what is my anion in this acid. So I have ClO. So ClO is hypochlorite. So it's hypochlorite. So ite becomes us. So I have hypochlorous acid. So hypochlorous acid. Okay, so I want you guys to try these 3 on your own as practice, and then check back with the key to see the correct answers. Okay? All right. So now I am going to give you guys, we're now going to switch gears and kind of figure out, well, that's good. We know how to name them. How do we get the formula? So we're going to kind of see if we can do that now. All right. So the first one is going to be hydroiodic acid. Hydroiodic acid. All right. And so for first thing I kind of need to figure out is this one binary or is it ternary? Basically, the easiest way to determine if it's binary or ternary is, does it start with hydro? Because all binary acids start with hydro. None of the ternary acids start with hydro. So this one starts with hydro, so we know it's a binary acid. All right. So we know it's binary, it's going to be made up of 2 elements. Because it's an acid, we know that our first element is going to be hydrogen. And hydrogen always has a +1 charge. And then our second element, it's going to be iodine. And I got that again just from right here. All right. I looked at my kind of root, iodic. All right, well, that's going to be iodine. So H and then I. And I is always a -1. So then we'll swap, drop, reduce, and we end up with HI as our first acid there. All right. So then we have chloric acid. Okay, it doesn't start with hydro, so we know it's going to be a ternary acid. All right, so in ternary acids, we kind of have to look at our ending to figure out which polyatomic ion it is. Since this one ends in ic, we know that its original ending was 8, so that's chlorate. So we have hydrogen and chlorate as our acid here. So we have hydrogen, because it's an acid, it's always going to be hydrogen, so H plus. And then we have chlorate, which is ClO3 -1. All right, so swap, drop, reduce there. We end up with HClO3. Okay. Next, we have phosphorus acid. So we have phosphorus acid. So same thing again, all right? Doesn't have that hydro, so we know it's a ternary acid. This one ends in us. So us was initially ite. So we have phosphite here. So we have H, because it's an acid, and then we have phosphite. So that is PO3 with a -3. Swap, drop, reduce, and we end up with H3PO3. Okay. All right. So next we have hyposulfuric acid. All right. Now, hyposulfate is, I'm thinking this is a typo, and it should say hydrosulfuric acid. I think I probably just typoed because there's no such thing as hyposulfate. My bad. So hydrosulfuric acid. All right. So let's go ahead and name that one. So starts with hydro. So I'll probably fix that on y'all's notes, so you probably won't even see this. So starts with hydro. So hydrosulfuric acid. All right. Starts with hydro, so it is binary. So we have H plus. All right. And then we need to figure out what the second half of that would be. So we have sulfur there. All right. So our second element will be sulfur. So that's S -2. So we swap, drop, reduce, and we end up with H2S. All right. And then finally, one more, hydrochloric acid. All right. So again, it starts with that hydro. All right. And so it starts with hydro. So it's binary. All right. So it's an acid, so we know it's going to start with H. Second part of that is that chlor right there. So that tells me it's chlorine because it's binary. So it's going to be H and then Cl -1. So when we swap, drop, reduce, we end up with HCl. All right, guys, and I want you guys to try these 5 on your own. All right. And then check the key. Okay, so last kind of little part of this is I'm just going to go through some of the common acids and common bases really quickly and just kind of talk about basically talk about the fact that they're the common acids and the common bases here. All right, so for our first one, we have HC2H3O2. All right, so it's a ternary acid made up of 3 or more elements there. Our polyatomic ion that it is made up of is acetate, so C2H3O2. So that 8 becomes ic, so this is acetic acid. All right, that's actually vinegar. Fun fact. Vinegar it's not pure acetic acid, but it's diluted acetic acid. So fun fact Fun fact for all of you. Our next one is HBr. It is a binary acid. So it's going to start with hydro, and then we would have hydro, the root of our anion, so bromic acid. Then we have HF, also binary. So once again, hydrofluoric acid here. All right, and we have H2SO4, it's ternary. SO4 is sulfate, so 8 becomes ic, so this is sulfuric acid. And then H2SO3 is sulfite. So this one is ite becomes us. So this one is sulfurous acid. Almost forgot acid there. Then we have HNO2. NO2 is nitrite. So this is nitrous because ite becomes us. Nitrous acid. And then finally, last but not least, we have HNO3, which is NO3 is nitrate. 8 becomes ic. So this is nitric acid. All right. So then over here we have, so those are just common acids. These are ones that really and truly you guys will see in most of your problems are going to probably be based on like one of these, just because they're really commonly used. But yeah. All right, so then we have common bases. Guys, bases are just the same. They're named exactly the same as any other ionic compound. So metal, and then your non-metal or polyatomic ion. So in this case, we have like NaOH. Well, Na is sodium. OH is hydroxide. All right. KOH. K is potassium. And again, OH is hydroxide. All right. Same thing, lithium. And then hydroxide. Calcium. Hydroxide. And then barium hydroxide. Hopefully you get the idea. And then kind of our last one down here is the only thing about this one is that iron is a polyatomic ion. So we need to include our charge there. All right. If you kind of think about it, hydroxide has a negative 1 charge. It's 3 hydroxides. So that means iron has to have positive 3 charge. So we end up with iron 3 hydroxide. All right, guys. So that is about naming acids and bases. So feel free to check, do those practice problems that I left for you guys, and then check the key that I'll post on Canvas for you. All right? Cool.